Okay. Grade 8, we're doing chapter 4, lesson 7, linear and nonlinear functions, November 11, 2020. As you can see, your new vocabulary is you must know what is a nonlinear function. That means it is a function, but it is not linear. Okay? So remember from when we defined a function is an equation or a graph or a table is a function because one domain has exactly one range. That is what a function is. Okay? It is a relation where one domain, so a function is a relation where one domain has exactly one range. So that is why it is a function. Now you need to know why it is nonlinear. So how many types of functions do we have? We have linear functions and we have nonlinear functions. So that we have two. There are two types of functions, linear and nonlinear functions. So you need to know the difference between the two, okay? Now, you need to know from a table, you need to know from a graph, you need to know from an equation. These three things. You should know from a graph, a table, or what did I say? An equation, yes. A graph, a table, and an equation. So now, let us look. When given a table, how do you know a function is linear or nonlinear? So the first thing is you remember what we did in chapter 3, lesson 1. You check if there is a constant rate of change. If there is a constant rate of change, then it is linear. If there is no constant rate of change, then it is nonlinear. So now how do we check for constant rate of change? We just do our arrows. Okay, what do I notice? My numbers are increasing, so I will put plus because they are increasing. Now I need to know by how much. 2 plus what? 2 plus 2 is 4. 4 plus 2 is 2. 6 plus 2 is 8. 8 plus 2 is 10. I cannot stop here just because I did X. I also have to do Y. When you're checking for constant rate of change, you must check for both X and Y. You cannot just check for X and say, yes, there is a constant rate of change. Now, let us do Y. What do you notice? Your numbers are increasing. So I do my arrow and put my plus. Now, 10 plus 2. 12 plus 2 is 14. So 12 plus 4. 16 plus 8. 24 plus 10. Now this is nonlinear because y is increasing by a different number every time. So I will write this function is nonlinear. Okay? This function is nonlinear because the rate of change is not constant. Let me justify my reason. Because y is increasing by a different value each time. By a different value each time. Okay? So that's how I've answered. I have justified my reasoning and I have explained why, and I have shown my work. All these steps are important for you to determine whether it is linear or not. Let's look at this table. My numbers are increasing on X, or my values are increasing on X. How do I know? Because they are growing. 18 is bigger than 9, 27 is bigger than 18, 36 is bigger than 20, so that's increasing. Now I need to know by how much. 9 plus what is 18? 9 plus 9. 18 plus 9. 27 plus 9. 36 plus 9. So each time my X is increasing by the same value, which is 9. What is happening here? My numbers are decreasing. They're becoming smaller. Negative 14 is smaller than negative 10. Negative 18 is smaller than negative 14. Negative 22 is smaller than negative 18. Negative 26 is smaller than negative 22. Now I need to know by how much. So what will I do? I will do negative 14 minus negative 10. That will become plus negative 14 plus 10 is negative 4. So each time I will subtract negative 4. So let me see if that is true. What is negative 14 minus 4, sorry. Because I said each time I'm subtracting 4. Negative 14 minus 4, negative 18. So there, negative 4. Negative 18 minus 4, negative 22. Negative 22 minus 4, negative 26. Okay? So how do you check? You check by minusing the number below with the number on top of it. How much you are subtracting. Okay, what do I notice? All my y's are decreasing by the same number. All my x's are increasing by the same number. So therefore, we have a constant rate of change. Okay? So I will write as x is increasing, as x is increasing by 9 each time, and y is decreasing by 4 each time. Remember, decreasing means minus. That's why I didn't write negative 4. Okay? And y is decreasing by 4 each time. The rate of change is constant. So this function is linear. So this function is linear. When you're writing your justification, you have to talk about what is happening in x and what is happening in y. The same thing here. When you're talking about nonlinear, you just say which one is not doing the constant. But when you're talking about the linear, you have to talk about both x and y. You have to talk about x and you have to talk about y before you say the rate is constant. And then you say the function is linear. Okay? So here when you find out that either your x is not the same or your y is not the same, you talk about the one that is not the same. Okay? All right. So sometimes also x can also be not the same and y can also not be all the same. So that means it is nonlinear. All right. What happens when they give you an equation? If they give you an equation, all linear functions can be standard form or direct variation or slope-intercept form or point-slope form. If your equation is in those forms and your x does not have an exponent, then it is linear. So the most important part, x will always not have an exponent. X must be multiplied. If x is divided, it stops being linear. Okay? X must be multiplied. X cannot be in the denominator. X must be on the numerator. It must be when it is linear. Okay? So, if your equation is written in direct variation form, in slope-intercept form, in standard form, in point-slope form, and x does not have an exponent, then it is a linear function. So these are linear functions. Okay? Now, x is being divided. X has an exponent. Do you see that? X is under a square root. That means x, the exponent, is a fraction. And here, look, x is also used as an exponent. So x will have an exponent. X will be x will be the exponent. X will be divided. If you see any of these, then it is a non-linear function. Okay, I repeat again. If x is in the denominator, non-linear. X has an exponent, non-linear. X is under a square root, non-linear, or a root. If x is under any root, non-linear. Okay? All right. Let's look at the graphs. So, linear functions, the graphs will always be straight lines. So, there is only 3 linear functions. Diagonal down, diagonal up, horizontal. Diagonal down, diagonal up, horizontal. Only 3 of them. These are the only 3 linear functions. There is no more. Don't put the vertical line. It is not a linear function. It is a linear graph, but not a linear function. So, how do you justify your reasoning? This is a linear function because my points are on a straight line. That's it. That's all you have to say. If your points make a straight line, then it is linear. Now let's look at this. These graphs are all not straight lines, but they are all functions because each domain has one range. They pass the vertical line test. If I draw this, the vertical line just touches my graph at one point. So you're right, this is a nonlinear function because my points are not on a straight line. That's all you do. Okay, do your examples and I'll see you tomorrow.